These tables, I'm warning you, will come up in every single test and cycle and exam that you're going to have on this section because I love them. So let's go through them very, very carefully. First thing is you've got to have a periodic table next to you while you're doing this so that you can see exactly what you're up to. The symbol for carbon is a C. Carbon, by definition, has got 6 protons, which means its atomic number is 6. So there will always be a link between the atomic number and the protons, and the element and the symbols and the protons. Those are all going to link. The electrons is a little bit different. The electrons, the protons, and the electrons are equal to each other unless there's a charge. Okay? And then so that will cause you to add or subtract some. Neutrons and mass number are going to have a link to each other. They're not the same. You're going to take the mass number, which is A, and you're going to take away the neutrons in order to get the, you can take away the protons in order to get the number of neutrons. Charge is going to link somehow to your number of electrons. So let's see how that plays out. The mass number is always going to be equal to the protons plus the neutrons. So it's going to be these two together gives you the mass number. In this case, 6 plus 6 is 12. Because the protons and the electrons are equal to each other, they're both 6, in this case you're going to land up with neutral. The next one, protons are 2. From the fact that protons are 2, I can immediately say I have helium. Helium's symbol is He. The atomic number is 2. I can get that information straight away. It's like a little bit of a Sudoku puzzle. This you don't necessarily go from left to right. Then I know that I am going to take the protons plus the neutrons in order to get the mass number, which is 3. Because it is neutral, the protons are going to equal the electrons exactly, and therefore I am going to have 2 electrons. The next one, I have got a little bit less information. This one's a little bit trickier. I know that I've got 37 as a mass number, and I have got 20 as a number of neutrons. So I'm going to subtract 20 from 37, and that's going to give me my number of protons, which will be my atomic number, which because it's 17 is chlorine, and I can write the word chlorine, but it's not actually chlorine, it's going to be chloride. And the reason for that is because I have got a negative charge on it. Remember last year we learned that when it bonded or became negatively or positively charged, I was going to change the surname of the nonmetals to "ide." So this is chloride. Now, how do I know that it only has one negative charge? Chlorine is in group number 7 in the periodic table. Group number 8 has got argon in it. All elements wish to be like their nearest noble gas. So if chlorine had 17 electrons, but it would like to be like argon, which has got 18 electrons, how many electrons does it need to gain? It needs to gain 1 electron. So that extra electron gives it its negative charge, and it means that I would have 17 plus 1, 18 electrons. Let's see how this unfolds with a few more examples. Be, by definition, is beryllium. Remember that metals don't change their name when they get a charge. Beryllium, by definition, has always got 4 protons by definition. So it's number 4, which means its atomic number is 4. And if I take 9 minus 4, I am going to, so it's mass number minus atomic number will give me the number of neutrons at 5. Beryllium would then normally have 4 electrons, but because it's positively charged by 2, that means it's lost 2 of those electrons and has only got 2 electrons left. Next one is an atomic number of 18. That is by definition argon, and it has a symbol Ar, and its protons must be 18. The next thing is to subtract 38 and 18, or 18 from 38, and I land up with 20 neutrons. Then they tell me it's neutral, so the electrons is exactly equal to the protons, 18. Next one tells me that there's an atomic number of 14. By definition, that is therefore silicon, and silicon has a symbol of Si, And 14 as an atomic number means there must be 14 protons. Because it's neutral, I've also got 14 electrons. And my mass number, I'm going to take my protons plus my neutrons. So this turns out to be equal to 28. Next one is Al3+. Al, by definition, is aluminium. Because it's a metal, it does not change its name, so it's aluminium. Aluminium has got 13 protons by definition. Its atomic number is therefore 13. And if I want to get the mass number, I go protons plus neutrons. I don't just go to the periodic table. I use this isotope that's been given to me here. Turns out to be 26. They tell me it's positively charged. And the good news is that they've told me how positively charged. It's positively charged by 3. So normally there would be 13 electrons, but now I've lost 3 of them, so my number of electrons is 10. If they had just said positive and I didn't know about this 3+ over here, I would have gone, aluminium is in group 3. It would like to lose 3 electrons to become like its nearest noble gas, which is neon. So that is how I would know that it was 3+. On to the next table. So I have got 18 protons. By definition, we know that to be argon, and it was in the last table as well, so this is not particularly difficult, and the atomic number must be 18 as well. They tell me there are 18 electrons, which means it must be neutral. This time they want me to give AZ notation, so I'm going to go AR, and then I'm going to say, I have to, if it says AZ like that, that means I have to put the atomic number at the bottom and the mass number at the top. That's what AZ notation insists I do. The number of neutrons, I need to take away the protons or the atomic number away from the mass number, and I land up with 20 neutrons. The next one is fluorine with a little negative charge up there. So let's write everything in. Firstly, it's got a mass number of 19. It has an atomic number of 9. That means it's got 9 protons. Fluorine, when she changes her name, becomes fluoride because she's got a negative charge. And I need neutrons, which is equal to 19 minus 9, which is going to be equal to 10. And electrons would normally also be 9, but it's got 1 extra electron, so it's going to be 10. Number of protons is 2. That makes it helium. Helium is He. The helium's atomic number is 2. My protons plus my neutrons is going to give me my mass number of 3. I can now go AZ notation, 2 at the bottom, 3 at the top. And helium, maybe someone should have told you that was neutral as well. But because it's a noble gas, it's pretty much always going to be neutral. So it's got 2 electrons and no charge. Calcium, Ca. Calcium, by definition, has got 20 protons, an atomic number of 20. Mass number is going to be protons plus neutrons, so that's going to be 44. They tell me now it has got 18 electrons, which is 2 less than the expected 20 over here, which means it must have a 2+ charge. Putting in the rest of the information, this is 20 and this is 44. Next one, I have got an atomic number of 8. That means I've definitely also got 8 protons. What element has got 8 protons? It's oxygen. I'm going to stop there because I happen to have noticed that it's got 10 electrons. So 10 minus 8 means that it has got a 2 negative charge. That's got 2 extra electrons. So if it's got 2 extra electrons, it must have changed its name to oxide. So it's O, and it's got an atomic number of 8 and a mass number of 18. And my number of neutrons, I take my mass number minus my atomic number, and I land up with 18 minus 8 is 10.